Hey everyone, and welcome to episode 3 of Dreamspace TV here in One Microsoft Place in Dublin. We've lots planned to cover today. Let's hear about it.
So in today's episode, we're going to recap over our extension challenge in the last episode. We're also going to explore AI for humanitarian action, which was one of our AI for Good pillars. And finally, we're going to transition from visual programming to Python, which is a text-based programming language.
Yeah, can't wait.
So now we're going to look at our extension challenge from our previous episode. And in our previous episode, Amanda, we focused on a polar bear tracker.
Yeah.
So we used the Bluetooth antenna that's built into the microbit to send and receive messages. Okay, and what we focused in on was sending strings. But now for our challenge, we asked you to send an alert to the ranger to let the ranger know that the polar bear is either moving or stationary.
Yeah, exactly.
Okay, and what you might have noticed and what we hinted to in the last episode was that there's no way of directly sending music. You can send a string and a number and you can send a value, but you can't specifically send music. So what we hinted at was maybe to use a number. And looking over here at our polar bear's microbit, you can see that we've sent numbers. So we sent 1 and 0, okay? And what you might notice is we're sending the number 1 when the polar bear is moving. And the number 0 represents when the polar bear is actually stationary and not moving, okay? So over here on the ranger's microbit, I suppose it's important to note that we have to allow the ranger to be able to receive the received number. So the first thing we looked at in the last episode was how to receive a string. So now moving on to numbers, we have to allow it to receive numbers. And therefore, we use our conditional statements to say that if the received number was equal to 0, it would play a low musical tone, so a low C.
That would be Niamh then, so if it's 0 and we look back, we can see that's not moving.
Not moving,
yeah, so it's
exactly.
a low note. We hear a low sound, hopefully, when we test this, when it's not moving.
And if or else, the only other option, it would play a high note, which would mean the polar bear is on the move, so the polar bear is actually moving. So now let's test it out.
Definitely. So let's bear in mind what tones we're going to listen for here now.
Okay, so are we ready? I'll unmute.
Yeah. Cool. Works.
So what you might have noticed, I muted it there again in case it would keep occurring on the low beat if it weren't moving. So what you might have noticed, it took a little bit of time to change over to show that it was moving when I was pressing on the side of the polar bear's microbit. So now would be a good time to pause, seeing as we're transitioning from visual programming towards text-based programming in Python. So have a think about or maybe jot down any text-based programming languages you might have encountered before.
Okay, so you might have discussed and come up with a couple of examples of a text-based programming language. You could have had Java, JavaScript, C#, C++, Visual Basic. There's tons of programming languages. As Niamh mentioned, we are going to be working on Python. And like other languages, it has specific purposes. One of the really cool purposes for Python is actually to teach machines to learn, or machine learning. And we know now from in the last 2 episodes that machine learning is a fundamental part of AI. So one of the AI for Good pillars we're going to look at is AI for humanitarian action. Niamh, can you bring everyone through that?
Yes, so AI for humanitarian action can be really impactful in terms of natural disasters. And one organisation in which we work with is called HOT, so Humanitarian Open Street Mapping Team.
I actually brought that up there, Niamh, as well. Just have a look and see. So that sounds cool. What do they do? Maybe tell everyone.
Yeah, so they try to provide humanitarian aid and have the ability to act fast within communities in Africa. However, the problem that exists there is that it's really difficult to locate roads and buildings and landmarks due to a lack of mapping.
Yeah.
And I suppose that's the theory behind what they do. But one example of how this was extremely important was back in 2015 when a severe earthquake hit Nepal and almost 9,000 people lost their lives.
Okay, yeah.
So I suppose what happened then was HOT sprung into action and they connected with the on-the-ground volunteers and used AI in order to create maps. So they
Right.
were able to identify where there was road blockages due to the natural disaster, and then they were able to identify areas where the helicopter could land.
Okay, to rescue people and stuff.
Exactly. So it
Okay.
was the difference between life and death.
Right, yeah. So it shows like the tremendous impact and how powerful it all can be, which is really useful to bear in mind again when we're looking at programming languages, because behind that AI are programming languages. And like we said, we're going to get stuck into Python now. But before we do so, we do want you to pause and first of all recap over all the coding concepts we've done to this point, and then also get ready to code on makecode.microbit.org. Okay, so hopefully on reflection of episode 1 and 2, you're able to jot down some coding concepts that we've covered so far. And we've done the same here. So Niamh, how about we just have a look and go through them?
Yeah, no problem. So sequence was the first one we looked at, and that's the order of your code.
Yeah, and then the next one we remembered, we definitely covered, were strings and numbers. So remember, strings were alphanumeric, numbers were numbers, but both of those things are just types of data within our program.
And then I suppose loops allowed us to repeat our code a set number of times.
Yeah, and then our variables, remember, were something that we created in our program, and then we could assign values to them.
And finally, our conditions were our if, then, else statements.
Perfect. So what we want to do is actually cover off these things now when we get into programming with Python. Okay, so hopefully now everyone is on makecode.microbit.org, good to go. And like always, we are going to go into a new project. And this time, because we are going to be starting with Python, we're going to type in Python 1. Well, I am. You can write what you want there. And I'm going to click Create. Now, something to bear in mind is, remember that we're hoping that at the end of these episodes, when we get to episode 6, that you'll feel really confident with all this stuff to enter the Do Your Bit competition. And what we would really, really love is for you to actually, if possible, do that program that you enter in Python. So let's see how we get on over the next few episodes with that anyway. So I'm in here now, like Niamh has been for the last 2 episodes, except this time when we look, we can see we're automatically in blocks. Now, for me, you can see there, Niamh, for me, it says Python is the next thing I can toggle over to. But actually for you, it could say JavaScript. So just to point out that beside that, there is an arrow. So I'm going to click on that. And you can see very clearly here, there's the 2 text-based programming options. We want Python. So I'm going to click on Python and allow it to toggle over. Now, the beauty of this is that obviously you can always toggle back. So we don't want to throw anyone in the deep end here. So as we're going through maybe different challenges, different aspects of this, you can always say, do you know what? I want to just see this in blocks first. And that's absolutely fine. When I learned to program in Python, I had initially learned all the fundamentals in blocks, like hopefully you have now, so that I felt a little bit more confident. But it's nice to have that option to toggle back. Right, so when I've toggled, I can see clearly here that I have already got 3 lines of code. And that's because there were 2 blocks on the screen at the start, as usual, on start and forever. Now I'm going to delete these lines of code because I don't want them. And we're going to, as we go here, we're going to kind of hopefully cover off on some syntax, which is basically the rules that are within this programming language. Python has certain syntax, okay? So I'll mention little kind of hints and tips as we go through it. This is a certain environment for Python as well. So this is something to bear in mind. You might use Python in another environment. And if you do, some of the stuff might be slightly different. Because we're talking about a physical piece of hardware, some of the code here for Python might look different to another environment. But the key thing is those concepts that we talked about, they'll stay the same across all programming languages. So if we can get our heads in the zone basically with those concepts, you can transfer your skills around other languages too. Okay? So I've the first line of code there. So the first thing, Niamh, I'm thinking of doing, just to keep all of us on track, is I'm going to use comments to kind of explain myself as I go. And this could be useful for you to do as we go as well. So to use a comment, what we do is we use a hash symbol and then we type out what we're going to do next. So I'm going to type in that here is a basic sequence.
And is that why it's after turning green, Amanda?
Exactly. So it's now green, and what this also means is that the program is not going to do anything. Like that isn't an instruction that can run, okay? So the hash symbol makes sure that gets eliminated. It's not going to be taken in by the program at all. It's nearly like a little note to yourself, and it can be really handy because it kind of reminds you, like if I come back to this next week, I can very quickly glance through my program and see my little notes or my comments and know exactly what I was doing with the program. Okay, so here is a basic sequence. That's line 1. I'm going to go down, and now we're actually going to do a basic sequence of instructions. So maybe 2 or 3 instructions need. And we're going to maybe do a mix of strings and numbers, just as we said, they were the data types that we've looked at so far. Now, when you do strings in other environments, you might use something called a print statement. It's slightly different for Python for the moment, so just bear with me on this one. What we're going to do is we're going to type the word basic. So basic, and what you'll see is automatically these options appear for you to choose from. So show number, show LEDs, everything basically that was within the basic menu. Now, okay, so you could click on these automatically. I'm going to just encourage you here, all right, to, if possible, actually type it out just to get yourselves in the right zone and the right frame of mind with this. A lot of programming languages don't have the option of populating this stuff for you. They've moved that way, which is really useful for people. Yeah. If you ask a programmer who learned how to program like 20 years ago, they'll be like, oh my God, I can't believe that's so handy, right? It'd save you lots of time, and it does. But just because you might be beginning now, it's useful just to practice this and type it all out. So I want to say basic.show underscore string, and I can see it's helping me there. I don't need to click on it, but I can use it as a guide. And then I'm going to open a bracket. When you open a bracket, you might notice, Niamh, there, you can see it there, that the close brackets come in as well.
Yeah.
So I'm going to enclose my string within that. So if I go in here, and I'm now going to do my quotation marks. And again, you'll see 2 come up to kind of get the start and the end. And now we can write in our first string. So Niamh, give us a shout there. I haven't really pre-thought of anything, so just call out something I can type in.
Maybe dream space.
Okay, perfect. Dream space. And there we go. Now, right, that's kind of the first instruction, and the string will always be done in this way, even if we use, as I said, the other version, which is a print statement. Something I want to point out, though, is how easy it is to make a mistake when we're using text, right? So all I would need to do to make a mistake here is even just lose that final quotation mark there. And if you look at my program, it's now going to quickly recognize that I have a problem. See down at the bottom and over here. And now nothing is going to happen for me. Okay, so I'm going to go and put the quotation mark back in. And let's go and test this out. So basically, when the microbit starts, we should see the string dream space. We'll click play here. And we are good to go. It's obviously quite long, but that's perfect. It's working. I'm happy. But that obviously isn't a sequence because, you know, there's no multiple instructions there, it's just one. So let's go and add another instruction. And actually, Niamh, if you don't mind, I might change that to DS just to speed us up. Okay, so we're going to go basic dot, and we're going to pick another instruction. I'm going to go show underscore icon this time. And you can see here, we can click on that and it will say what we can do. So icon names heart. Now what's cool is, because it's helped us a bit there, we can manipulate or alter this. So let's delete heart and see what else we can do instead. So I've gone back and I've done icon.names dot. And you can see these are all basically the preloaded icons we looked at before, Niamh, when we did the LEDs with the mindfulness picker. So we might go and pick any, you throw one out there, Niamh, sorry. Anyone jumping out at you?
There was one at the tortoise actually.
Yeah, perfect.
That might be a nice one.
You love animals, that's why. Right, okay, so there we go. So now we should see DS and this. Let's just test it, why not? As we go, let's test. So DS, and we should see our LEDs. Lovely. And let's do another one. So that's 2. Let's do a third. So basic dot show, and let's do a number this time. Show number, open my brackets, and let's put a number, any number. Any number, Niamh?
Maybe with the tortoise in mind, life underwater. So
oh, good shout.
The global goal, I think it's 14.
Yeah, Well remembered. Okay, 14. Okay, so there's our 3. So let's just really quickly test that again. And we'll see DS, tortoise, and 14. Happy days. Okay, so that's just a really basic sequence. Now, we sometimes with numbers, while we're just looking at numbers for a second, I want to just quickly touch on something that's often used in Python, which are called maths operations, or just operations. So Niamh, if you think about a couple of ways we use numbers in maths, what I might do is if you just call one out to me, I'll just quickly test it here. Is that all right? So if you want to call out any maths operation there.
Maybe addition?
Addition, okay. So how we would do this is, we still are saying basic.show us a number, except in here, inside our brackets, okay, what we do is we delete the 2 numbers that we wanted as a definite, which was just like show us 14. Now we want to do addition as the first one, so we might say 5, and it's still the same as you would normally do in maths actually for this one, plus. So it's straightforward enough. And let's just quickly check that one. So obviously what we're looking for now is DS, a tortoise, and 10. Yes.
Very good.
Perfect. So there's addition. Throw out another one to me.
Subtraction.
Okay, subtraction, perfect. So I'm going to go in, and instead of doing it all again, sure, we'll go just change plus to minus, and we shall test that. There we go, working a treat. Next.
Maybe multiplication this time.
Okay, well this one is a little bit different. So plus and minus is the same. So you're going to be very familiar with that from maths class, right? Multiplication isn't going to be an X the way you might write it like that. That's not right, okay? What we use in Python is an asterisk. So I'm going to use my asterisk as my multiplication, okay? So 5 times 5, or 5 multiplied by 5 is the asterisk. So let's just test it, and obviously we're looking for 25, if I remember my times tables properly from primary school. And there you go, 25.
Indeed.
Okay, we try division next maybe?
Yeah,
we'll
division.
keep going in the flow. So division again is going to be slightly different, everybody. So it's not going to be, there's no division symbol on your keyboard. So when you're coding, you can't use that. So what we use instead is a forward slash. Okay, so I'm going to use my forward slash test. You can see where we're going with this. And you might think she's really overdoing it on the testing there, but I guarantee you, the more programming you do, you'll realize how important the testing is. 1, we're good. Okay, perfect. So one more I do want to cover as well is called modulus. So the modulus symbol is actually the percentage symbol. So if I say, for example, 31, I'm going to delete our forward slash, and I'm going to use the percentage symbol, which is modulus, and 5. Now what happens here is these 2 numbers, it's a division. So it's going to be 31 divided by 5, which would be 6 with a remainder of 1. What modulus returns is the remainder. So in this instance, it should be 1. So let's just check and see. So we should see DS, tortoise, and 1. Yeah. Now, if so, again, like you can see very quickly, just real quick, if I change that to 32, it's still going to divide in 6 times, but this time the remainder would be 2. So that's just to prove that it does always return that remainder. Let's just test that once more. Tortoise 2. Okay, so you can see, so they're maths operations. So because we've covered them, I'm going to come down here. I'm going to put in a comment, if that's all right, Niamh.
Yep.
And I'm going to say operations that we've covered equals. We're going to say plus, minus, asterisk, forward slash for division, and modulus. Okay, so now would be a good time to pause and just do some basic instructions that you get the microbit to do on start using strings and numbers, and try out a couple of maths operations. Okay, so hopefully you've got a bit of practice in there, just doing some basic instructions with some maths operations in there too. So let's keep going. I'm going to go down a line into line 6. And what I want us to do now is we've done on start instructions. So we know our microbit is going to do those 3 things for us when it starts. But how about now we look at using one of our inputs? So Niamh, again, I'm not fussy. If you want to just give me an input to use, just call out any input.
Maybe let's use the button on button A and B pressed.
Oh yeah, we haven't used that yet actually, in fairness. So we've used A, we've used B in our code. We haven't used A and B together. So that's perfect, Niamh. Thanks, Mill. So I'm going to go input, because again, I'm going to, remember with the last one, we did basic first because we were taken from the basic menu. This is going to be an input, so I'm going to take it from the input menu. So I'm going to type in input, and you can see it's actually trying to generate it for me again. All right, dot on button pressed. I'm missing my underscore. And again, that would make a difference. So literally one character out and the whole thing wouldn't work. On button pressed. And I'm happy to click on it then. Okay, just to generate, it will generate a couple of things. And I do want to explain these to you. So I'm going to go down a line or two just to make this really clear. Okay. Now, automatically, when the input came in, similarly to when you would have dragged in the block for a button, its automatic preset is to A, which you can probably see there on the screen, okay? So it says def, which I'll explain in a second, on button pressed A, and then down here it says button A. Now, if we want to use button A and B together, we're going to need to change a couple of things. But before we even go there, I need to explain what these lines of code mean that automatically generated for me. And in that instance, I know I was saying practice, but in this instance, it is easier just to click on it so that they come in and then we can talk through them. Okay? So I'm going to put a little comment here to explain that this is going to introduce functions. Okay, now when we did our list at start there, Niamh, and we had all the different things we covered so far, functions was not on the list. But functions are actually a really important aspect of coding. And in Python in particular, we use functions a lot. When we use buttons with the microbit, they're kind of like preloaded to generate a function, which is why automatically this word came in. So when you see the word def, that's a key word and it means define. So when we create any function, even if we were creating it from scratch and it was nothing to do with a button, the very first thing we have to write is def, which defines our function. And what we do after def is we name it. Now, automatically, it has generated this name for us, but I think that's really long and a little bit confusing. So I'm going to change that to from on underscore button underscore pressed underscore A, because it's very long. I'm going to delete that, and I'm going to type practice instead. Now notice that I did not delete the brackets, which is so important. When we define a function, so we define it with a name, and after the name, we always have an open and a close bracket. Anytime you see that in a computer program, it means it's a function. And actually, like I mentioned, with the microbit, there's lots of automatically inbuilt functions that we don't need to make. They're already done for us, which is handy, but just to note that that's what that means. Okay, so I know I'm repeating myself here, but I want to make this really clear. We've defined the name of our function. We have an open and a closed bracket, and then you might notice there is a colon, which is also important. So after we define our function, we always add that too. Underneath here, by the way, it says pass. And that's because when we first brought in that line of code, there wasn't anything contained in the function yet. So what a function does is it contains a unit of code for us. It could be multiple lines of code within that one function. At the moment, there's nothing. That's why the word pass is there. So we're going to delete the word pass because we are going to add a unit of code to that now. And you can see that from my colon, when I hit return, my program automatically indents me, which is really important. So this is going to be, once it's indented, it means anything I do now, even if it's line after line after line, if it's indented, it's a part of this function. This is the unit now that I'm talking about that the function is containing. So my practice function, and the reason I said practice, by the way, Niamh, was I was just thinking we might just do a couple of things again, like strings, numbers, just change it up, right? So I'm going to do basic dot show string again. And I'm going to do, I'll just do my own initials. I did them backwards though. Then I'm going to do basic dot show arrow. And then I'm going to change north here. You can see it automatically populated for me to south. And then I'm going to do basic dot, just to have a couple of instructions inside our function, do a number. And again, we might just do an operation just to refresh the memory. call out an operation there, Niamh, anyone at all?
Maybe 5 divided by 2.
Okay. 5 divided by 2. Okay, perfect. And so there's 3 instructions within my function practice. Okay, now that's all good, but now we need to figure out, well, when do we want these to occur? Now, if you remember, so when we brought in our button, okay, it automatically populated all of these things. We've just edited line 8 and we've added 9, 10, and 11, okay? On line 12, let's just have a look at this for a second. It says input, dot on button pressed, and then it opens a bracket, and it says button dot A, which is its default, remember. It automatically is A unless we want to use a different button. And we decided at the start, Niamh, we wanted that to be A and B. So all we need to do here, guys, is add a B. So it's AB, okay? And now that's going to be that button, A and B together, all right? And then you can see here, Niamh, it's underlined here.
So I think that's really important because we need to remember that we need to call on our function. So we need to replace this with calling on our function.
Yeah, with the function name, exactly. So we have to call on our function here. And if you remember, the reason it's automatically populated this is, I don't know if you remember this now, but this was actually the name I deleted up here. So it already populated it, but I changed it. So if I change it here, I need to change it here too. So I'm going to delete this and I'm going to type in practice because that's what I actually changed that word to, okay? And as Niamh said, that's us calling on that function. So what this all means is we've made a function called practice which contains these 3 instructions, and we've now said on line 12 that when we press button A and B together, call on the function practice which should execute those 3 lines of code. So let's go and check if that works. And then we'll take a breath because I know that was a lot of information to take in. Okay, so let this refresh for a second. And you can see that on my simulator, A and B has appeared for me to test. So I'm going to click here. And just before I click, I want you to think carefully, what should we see when Amanda clicks A and B at the same time? Okay, so I'm going to click it. Okay, so it's executing the unit of code within my function. There we go, 2.5, which is 5 divided by 2. Perfect. Okay, so that was a lot. So we are now going to say it's a good time to pause because we think it would be nice for you to go and bring in a button or an input of your choice, create a function for that, and then call on that function with the input of your choice. Okay, so hopefully you got all right that. I know functions are a new concept, but they're going to be important because, as I mentioned, they automatically populate when we use any inputs. So if we want to do something other than on start, you're going to have to understand the functions piece, okay? So hopefully that was all right. Now, before we keep going, we might just have a little recap over the coding concepts just to see what we've looked at so far within Python. So let's see. So we've definitely covered sequences. We've definitely done strings and numbers. We haven't done loops actually, so we might have a look at that in a second.
Yep.
Variables we haven't covered, but I would like to maybe leave that to the next episode. However, I would like to look at conditions.
Yep.
And then maybe we can add what we've done today, which is functions, because that actually is a really important concept to talk about. So we can kind of add that to our list and remember that then as we're moving forwards. Okay. Thanks, Niamh. So perfect. So what we might do very quickly is quickly look at a loop and then finish out by looking at some conditions within our program.
Sounds
that sound
good.
Okay? Hopefully that's all right and we're good. Okay. Right, we're going to go back to this. I'm going to add a comment again and I'm going to say, let me see, add a loop. Now we mentioned that there's 2 types of loops in our program. There's a for loop and a while loop. And so far in the other episodes, we've only used a for loop when we gave a certain amount of times. I think we'll do that now, but in another episode, we will look at the while loop, which is a different type, okay? So to add a loop, I'm going to do something that programmers do a lot, which is copy and paste their code. there's no need for me to rewrite things if I want to just demo something or I want to keep aspects of it. All right, so what I'm going to do is I'm actually going to come up here. I'm going to copy and paste this. And to do this, I've just highlighted it. And on my keyboard, I'm going to say Control C. Now, you might want to right click and copy, which is no problem. And then I'm going to come down to line 15. And I'm going to go Control V to paste, or you can just do right click and paste. Now, automatically, I have a problem. And it's similar to what you did in even one of the episodes when you brought out a second button and it went error. So it's basically the same thing here. It's telling me you can't obviously use the same button again, and also the function is the same name, which isn't the best idea. So I'm going to change my practice function to practice 2. So it's actually pretty much a new function. And just to change it up, I might just change my initials. I might put in your initials, Niamh, instead. And we might just change our division there as well. Okay, just to change up the instructions within my function practice 2. And then the final little thing I want to change is that I want to maybe change, will we try button B this time?
Yeah.
So when I come down here, I want to just double check this. So input on button pressed is fine. Button dot, I want this to be button B. And remember now, I'm not calling on practice, I'm calling on practice 2. Okay, so I want to match it up with my function name here on line 15. Okay, so stay with me on this. We want to now add a loop. So instead of this only happening once when we call on it, I want it to happen maybe twice, right? So it's going to do the 3 lines of code 2 times. So that's going to be a loop that we need. So if I come in here to my colon, I'm going to just go down. And I'm going to add my for loop in here on line 16. And hopefully I explain it okay. I'm going to write in here for, okay, I, which is going to be my variable, in range, and I'm going to put in here 2. So that means that the variable, basically I, that you can see down here, that variable is going to iterate through this range below 2 times. I could change this to 10, change it to 15. So I'm going to leave it as 2 though in this case. Now, one thing I want to point out is if you remember our loop block, Niamh, when you brought it in, it wrapped around the instructions. So they all kind of moved in a space. So that's similar to what I do need to do with these lines here. I need to come in and just move them. I need to indent them so that they're within my for loop. Okay? So now when we call on our function using button B, we're going to call on practice 2. Practice 2 is this unit of code which should repeat twice. So let's go and test that. Oh, I have an error. Let me see. Aha, okay, line 16. So this is the cool thing, it's telling me, yes. Okay, so I had a bug there. So as you can see, very easy to make those mistakes, especially when you're me. So we are going to come up here. The mistake is that similarly to up here, when I finished my keyword after for, I need to put in a colon. Okay, that was the error there. And then again, remember, it automatically would indent if I went down. Okay, so I'm going to, now that should work. And remember, the input we've said is B. So when we press B, we're calling on this unit of code. Let's check this works. So here we go. Yeah, so there's Niamh's initials. We're going to have an arrow. We're going to have 5. And there we go again. Okay, perfect. Happy enough. Okay, so that is our loop. Now, you don't need to do that. I just want to show you that so you can test it out there yourselves if you want. If not, don't worry, because we will cover loops again. Our final thing we wanted to do that I mentioned, Niamh, were conditions.
Yes.
Okay, so what we were thinking is, how about we use one of the inbuilt sensors like temperature?
Yeah. Sounds good.
And have a look at how we could get the microbit to nearly pick up on the temperature wherever it is and then do different things as a result of that temperature. So that's obviously different situations, so that's why our conditions are useful. And if we think back to our global goals, actually, one of the goals is, if I check the number again, 7 is renewable energy or energy efficiency. So it's obviously a really useful way. If we know the temperature in a room, it can maybe respond, heating might go on, heating might go off, depending on whatever the temperature is. So that's kind of a nice way of being energy efficient. So let's do a comment to say what we're going to do here. So we're going to do a temperature monitor. Okay, and let's go down to line, oh, sorry, apologies. I need to delete that. I don't know why that generated. It's the only thing sometimes when it prompts you, it does some mad stuff. Okay, I'm going to go down to line 23. We're flying it. Look at all the lines of code we've done. Well done. Okay, if you're with me, hopefully you're still with me. Okay, so we're going to do a temperature monitor. Right, Niamh. So what we want to do here is we want the microbit to kind of take note of the temperature and respond accordingly.
Okay.
Is that okay? So I think what we'll do is we might do this as part of, let me think, another input. So
Yeah.
maybe on shake?
Yeah.
Okay, so we're going to bring in an on shake input. So again, if that's an input, I start with the word input. And this time, just to speed us up, it's not a button, it's a gesture. So a gesture or a movement. So I'm going to click on that. And it has done what it did with our buttons in that it brings in a couple of lines of code, okay? So we have on underscore gesture underscore shake, pass, because we've nothing inside that function yet, and then we have when we call on it, the line that allows us to call on it. I'm going to change this to temp monitor. And you might notice there I've used a lowercase t and an uppercase m. That's called camel case. You might just see that come up a lot. It's just to separate words because we can't put like spaces here. That's not allowed. So we use that instead. Okay, that's all good. I've defined my function as this. And now I need to just decide what is that temperature monitor going to do. So conditions, remember, were our if, else if, or else statements, okay? So the reason I've said it that way and I haven't used the word then is we don't need to type the word then in this case. We're going to say if something, or else if something, or else, okay? And we actually don't even say else if. We say ELIF, elif, just to speed us up, okay? So here we go. So here's our temperature monitor. So we're going to say if, okay? And you can see it's a keyword, it's gone blue. If. And now we're talking about temperature, which remember is part of what category, Niamh?
Is our sensor, so our inputs.
In our inputs, exactly. So I'm going to say if input dot, temperature. I'm going to click on that, speed me up. And you can see that's an inbuilt function, don't worry about that. If the input temperature, and we might start with what we wanted to do if it's too low. So if it's
Maybe
cold, so less than
8.
Less than 8, okay, so I'm going to do less than 8, and then I'm going to do my colon, and I'm going to drop down a line. So in here now is what we decide to do with that condition. So if it's less than 8, what will I do? Will I say print something? Or?
Yeah, maybe print cold.
Okay, so we could use a print statement here, but I think I might show you that in the next episode. So instead I'm going to just stick with what we've known, which is to show a string. So basic.show string. And you said cold, Niamh?
Yeah.
Okay.
I'm a cold creature, so if it's under 8, I definitely want the heating on.
You'd have the hoodie on, right? Okay, perfect. So if it's less than 8, we should see the string cold. Okay, let's go down a line, and I'm going to come back out of that because that's all I want to happen for that statement. So for that condition, that's it. I'm going to come back out one, and I'm going to say elif, which remember means else if. Okay, so elif input dot temperature, it's the same as the last time. And we might do whatever if it's like it is warm, so greater than
maybe 15.
Okay, perfect. Greater than 15. And again, my colon, come down, and we'll say basic dot show string, Niamh, whatever, just say
maybe
warm.
hot or warm this time.
Yeah. Okay, say hot, sure. I think that was your first instinct, so that's all good. Okay. And then we are going to use an else statement as well. So I'm going to come down a line. That's all I want to happen for that condition. So I'm going to come back out and I'm going to say else. Okay? And else colon, because again, you remember it's going to know what's left. And what is left here is anything between 8 and 15. So if you think about this, if it's not less than 8 and it's not greater than 15, that's what's left behind. So that range between 8 and 15 basically. And we might just say, how about, what are we thinking?
Perfect.
Perfect,
Just
yeah.
right, perfect.
Just right, it's like the Goldilocks. Right, okay, all right, so Nearly there, stay with me. So that's our function temp monitor. So when we call in that function, it's going to check for these situations and react accordingly, hopefully, if it works. And then if I come down to line 30, we just need to check we're going to call in the function correctly. So input on gesture, gesture.shake, that's good, we're happy with shake. But remember, here needs to be our function name that we're calling on, which was temp monitor. So I need to type that in, temp monitor. Okay? Now, test.
Yes.
I'm a bit nervous, so hopefully it works. Okay, so that was just our on start instruction. You can see shake has appeared now. So I'm gonna shake. It says 21 and it's saying hot, which is correct. And if I come over here to my simulator, I can actually drag that bar down to test the other conditions. So I'm gonna go to 3 degrees and shake, cold. Woohoo! And I'm gonna come up to 41, hot. Happy days. And actually, sorry, in the middle, I already did hot, sorry. We already checked that one. So what am I looking for? I'm looking for between 8 and 15. So if I go down to 10. Perfect, great.
Great.
Okay, so there's my 3 conditions working perfectly. I'm happy with that. And to be honest, I think that's a lot to have covered. So I'm happy to stop there. And I'm sure you'll be happy I'm stopping there too.
So for today's extension challenge, we'd like you to look at Amanda's code, and based on Amanda's code from line 23 onwards, which is our temperature monitor, we'd like you to come up with some sort of a light monitor. So bearing in mind a light is also a sensor which can be found in the input section. And just try and figure out how you could maybe manipulate the light if the light is too bright or too dark.
Exactly, perfect.
But before we finish up, let's have a look at, did we cover everything we aimed to cover in this episode?
Hopefully we did, I hope.
I think we did. So we recapped over our extension challenge from the previous episode. We explored AI for humanitarian action. And finally, we moved on to Python. So we got a lot covered.
Yeah, we certainly got a lot covered, and hopefully it was enough to whet your appetite to be excited to continue with Python now. Because remember, hopefully you can enter the Do Your Bit challenge using a Python program, fingers crossed. If not, even with that extension challenge, feel free to toggle back to blocks. If you do need that kind of jumping back and forth, don't be lost at all, and keep us posted on how you're getting on as well. Join us next time and we'll chat to you then. See ya.